Yes,
Okay,
sir.
okay then. In this small 5 minutes lecture, we will try to cover the entire wave optics through a quick revision using our mind maps. We have done a quick revision of ray optics using our mind maps, and now we will try to repeat the same feat for quick revision on wave optics. So let us go through the quick revision of wave optics, and let us first confront the first heading, and the first heading is known as Huygens principle. Now, we have not discussed this Huygens principle in the class, so what I'm going to do is just tell you this Huygens principle. Do you see this Huygens principle? This is Huygens principle. So what did this Huygens principle say? Whenever you have a light wave and it is moving, it is propagating, it propagates in the form of wave fronts. Do we know wave front? Yes or no? Wave front, what we have drawn are wave fronts. Wave fronts are locus of all points which are vibrating in the same phase. Can you note it down, beta? Wave
Yes,
front is the, whenever wave is traveling, we have found out the superposition. We have drawn wave fronts like this. These wave fronts are nothing but locus of all particles which are in the same phase. Remember, for a spherical wave front, the intensity is inversely proportional to r square, or the amplitude is inversely proportional to r. Huygens principle states that all these wave fronts, every point on this wave front becomes a source and it emits secondary wavelets. We have seen it in diffraction. In diffraction, we had seen that we have superposition of infinite number of sources coming from the same wavefront. Do we remember this? Those infinite sources are coming by the principle of Huygens, that every point on the wavefront will become a source. Do we understand this?
yes, sir.
That is your Huygens principle about how wave propagates and how every wavefront can become a source of infinite point sources. Now we move on to our interference. Do we remember this formula for constructive and destructive interference? Do we remember the formula I or A is equal to root over? Let me write it here. Do we remember that formula for intensity of a wave?
Yes, sir.
The amplitude, the formula of amplitude was under root of A1 square plus A2 square plus 2 times A1 H2 cos theta. Remember that?
Yes, sir.
And if it is constructive interference, it happens when the value of theta is even multiples of pi. Sorry, or multiples of pi. We have seen what happens for constructive interference. Amplitude becomes A1 plus A2, and for destructive interference, amplitude becomes A1 minus A2. Do we remember this?
Yes, sir.
That was about constructive and destructive interference. If I go back to the next one, which is the Young's double slit experiment, we had seen in Young's double slit experiment, the fringe width is d lambda by d. All fringes have equal fringe width and they have equal intensities. Yes or no?
Yes, sir.
To find the distance between nth bright and or nth dark, we can just multiply it by n times d lambda by d, and that is how you can get the distance between any two fringes. Do we remember this, bacha?
Yes, sir.
Okay, then we had also seen what is the path difference for constructive interference or bright fringe, and path difference for destructive interference. Do you remember this? Remember, you have seen it as 2n minus 1. where n starting from 1. If I use this formula, n will start from 0. Do we understand this? Can I have some raise hand that we understand this, bacha?
Yes, sir.
And again, if you want to find the distance between NA dark and central bright, you might not be asked this, but you can use this formula. This formula comes from the original formula. It might look very confusing, but this is 2n minus 1 d lambda by d. Do we understand this?
Yes, sir.
So all these formulas are given at one place, and this place is your mind map. We have also seen that for interference to happen, the two sources must be coherent. Yes or no? No or yes? And for coherent sources, they must have a constant phase difference between them. Yes or no?
Yes, sir.
Okay, that was coherent sources. Then we had moved on to diffraction by a single slit, and we had seen the formula for diffraction by a single slit. We had seen that in a single slit, for part difference n lambda, we have dark films. Yes or no? And for 2n plus 1 lambda by 2, we have bright bright fringes. Yes or no? Remember this?
Yes, sir.
Okay, here this is given ulta. So the width of the central bright fringe is 2 times lambda by d, and the angular width, just correct it, and the angular width is 2 times lambda by b. The terms have interchanged. Do we understand this? This is all about diffraction given in a single sheet, single page. Do we understand this, beta?
Yes, sir.
Then the last thing, but not the least, that we did was Brewster Law in polarization. No, the last thing, the next thing that we did was what is polarization. So polarization is nothing but restricting the vibration of electric field in a direction which is perpendicular to the direction of wave. Do we remember this?
Yes, sir.
And we have then seen what is your Brewster law. If the angle of incidence is your polarizing angle, then your reflected ray becomes completely polarized and your refracted ray becomes partly polarized. Do we remember this?
Yes, sir.
Pakka?
Yes, sir.
Well, then this is your entire wave optics in one single sheet. I have already shared that sheet with you. And right now, I'll show you on the screen the entire sheet, part of the same sheet, and I have shown it to you. You can go through this sheet. This entire sheet will cover everything that you need to know. We have not covered resolving power of telescope and resolving power of microscope. So that is not part of your curriculum. Do we understand this?
Yes, sir.
Well, then with this, we come to an end of your chapter on wave optics. We have covered all the three things: interference, diffraction, and polarization. In the next class, we will begin with the next topic. I will send you the sheet for the next topic. So I'll see you with the next topic in the next lecture. Take care and have a very nice day, bacha. May God bless you all.